Chapter 7.2, Volume by the Disk Method. Right? Finding the volume of a solid with known cross-sections. Right? The last video we talked about if you have a shape and you build upon the shape using known cross-sections. For instance, if you have this shape and you build squares on top of it. Not an artist, so I'm not the best sketcher here. But you can see we get something, it kind of looks like that. And we discussed how to find the volume of that shape. And basically what it was is you're finding the volume of the shape that's your cross-section, and then you're adding up infinite amount of those shapes that are infinitesimally small. All right, so here's an example. This is from an old AP test. It's going to be more than just cross-sectional area. It'll be some rotations and some, or cross-sectional volume, be some rotations in area. But let R be the region in the first quadrant, bounded by y equals 2 square root of x, the horizontal line, and the y-axis. Write, but do not evaluate, an integral expression that gives the volume of the solid when R is rotated around the horizontal line, y equals 7. So y equals 7 would be right up here. So we want to rotate. And we'll rotate perpendicular to the x-axis so that we can use our washers. So our volume for washers would be pi from A to B of the larger radius with respect to x squared minus the smaller radius in terms of x squared with respect to x. All right. A and B are the x values. You can see 0 and 9 are A and B. So it'll be pi from 0 to 9. Now our large radius of rotation, since we are rotating around this axis, our large radius of rotation will be from the line y equals 7. If we look, we go down to here, which you need to kind of think of it as you're rotating around y equals 7. This is 7 units long. But you're not using the whole 7, you're using 7, but you're going to take off this little piece. So our radius of rotation is 7 minus the function that's further away from the axis of rotation. So that'll be 7 minus 2 square root of x squared. Our small radius of rotation will be 7, because you go down to here, and then you come back up to this line, which is 6. 7 minus 6. Well, you can go ahead and write that as 1, right? So that is a solid generated by rotating around y equals 7. R is the region. Region R is based on a solid from 0 to 6. The cross-section of the solid taken perpendicular to the y-axis. Perpendicular y-axis will be like this. That means we're going to have an x equals equation. So the cross-section solid is a rectangle whose height is 3 times the length of its base. Well, first off, the area for a rectangle is base times height, and the height is 3 times the base. So this will be base times 3 times the base. In other words, we'll have 3 times the base squared. So we're going to integrate all those rectangles. Because it's perpendicular y, we're going to use the y value. So our volume will be from 0 to 6 of 6 times base squared with respect to y. And then we just need to figure out the equation for base. And base is just this line here, which is the length of the function in terms of y. So we need to take our function and solve it for y. So we'll divide by 2 and square it. So x equals 1/4 y squared. So our volume is 6 times the integrand from 0 to 6. Sorry, 3, because it's 3 here. Three times the integrand from 0 to 6, sorry for those of you I confused, of this line minus that line to get that value in there. Since the last line is 0, we can just do 1/4 y squared squared with respect to y. All right, our next question is also an old AP exam. Number 4, R is the region enclosed by 2x and x squared, as shown in the figure. The region of the base is a solid. And for this solid, at each x, the cross-sectional perpendicular to the x-axis has an area of, so each of the cross-sections, they're telling us what the area of each cross-section was. So what we need to do is take these areas and just add them up from 0 to 2. So the volume will be the areas from 0 to 2 of sine pi over 2 x squared. Oh no, that is the area, so we don't need to square it. With respect to x. Does it say find it or just set it up? It says find it, so we need to integrate it. Let's let u equal pi over 2x. du is pi over 2 dx. We have the dx. We need the pi over 2, so I'm going to put the pi over 2 there. Then I need to balance it, so I'll put 2 over pi to balance it. So we got 2 over pi of sine of u du. If the limit is 0 in x, it's 0 in u when we plug it in. If the limit is 2 in x, we plug it in, it becomes pi in u. All right, then as we continue, the antiderivative of sine is negative cosine from 0 to pi. Don't forget your 2 over pi. So we got 2 over pi, negative cosine of pi. Cosine of pi is negative 1, minus negative 1. Because we got negative here, cosine is negative 1 minus negative 1. That's going to give us 2 over pi. That's times 2, or 4 over pi. All right. Another practice problem here. Another solid has the same base, r. For this solid, the cross sections perpendicular to the y-axis are squares. So we're doing it this way. Right, but do not evaluate an integral expression for the volume of this solid. So we need to solve each of these. Since we're perpendicular to y, we need to solve for x. So we got it in terms of y. So x equals 1/2 y, and x equals the square root of y. So our volume, as we wrote, right, as we were squares, okay, our volume will be, if we're with respect to y, we use the y value, so it'll be from 0 to 4. The area of a square is your base squared with respect to y. So from 0 to 4, our base is the parabola to the line. The parabola is the square root of y minus the line, which is 1/2 y squared dy. So in conclusion, if you're looking for a volume of a shape with known cross sections, that's where you have an area that you're building upon. What you're going to do is you're going to first find the area of the cross sections. And then add them up. Add up all cross sections. And so if you're perpendicular to x, that's going to look like volume from A to B. Our area of whatever our cross section is in terms of x with respect to x. Usually there will be a squared involved. If you're with respect to y, Won't be much different. You'll just go dy instead of dx of the area in terms of y with respect to y.